Happy Wednesday, it's time for another daily coding problem. These problems are all kind of like technical interview questions that either come from LeetCode.com. They have a list of interview questions on there. They don't tell you what company they come from though. And then the other place that I get these is from dailycodingproblem.com. It's an email newsletter. Every day you get an email. It's got a problem, an estimated difficulty, and then it tells you the company it came from. Today's question here comes from LeetCode. And I like these because when we're done, we can go to LeetCode.com and upload our solution and run all their test cases to make sure that it actually works. So it's kind of fun when I finish this video to dump it up there and make sure everything works. Let's read it. So you are given an n by n 2D matrix representing an image. Rotate the image by 90 degrees clockwise. Note, you have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not allocate another 2D matrix and do the rotation. So we can't use any additional space. We have to do it in place. Okay, that makes sense. And they've given no requirements whatsoever about performance, so we don't care about that for this. And usually, sometimes you can optimize both, but as we've seen in a bunch of problems we've done already, usually if you optimize space, then you sacrifice a little time, and if you optimize time, you sacrifice a little space. So in this case, we want to optimize for space, and we don't necessarily care about time. I'm going to start my stopwatch now, so that we don't spend too long working on this. Don't want to head down a big old rabbit hole or something. So let's look at the examples they've given us. It looks like they've given us two. So we've got example 1 here, which is a 3x3 array. And our inputs look like they're just integers, right? So that's nice. And our input is 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we rotate that 90 degrees clockwise, we would expect to see 7, 4, 1. I'm looking at the output now just below. So 7, 4, 1. And then up here, 8, 5, 2. And then our last row, 9, 6, 3. So that makes sense, right? And then example 2 is just another example of a different size, it looks like. So this is a 4x4. And let's make sure it makes sense as well. So if we rotate clockwise, we're going to have 15, 13, 2, 5. 15, 13, 2, 5. And then we're going to have 4, 3, 4, 14, 3, 4, 1. Which we have here, 14, 3, 4, 1, et cetera, et cetera. Okay, cool. So we've got two examples. These are going to be our test cases. So I'm going to grab them and let's open up a test and start writing an actual test with these in there. So this is rotating a 2D matrix. So let's call it matrix test. And it's going to use mini test auto run for running our tests. And then we're going to use mini test pride as well. So we get color in our output, reds and greens. And then, of course, we need to require the file that we're actually going to test, which we've called matrix, right? Let's describe what that looks like using the examples they've given us. And we're going to have a function that does our work, which we can call rotate, right? We're just rotating some stuff. So it rotates the matrix 90 degrees clockwise. Okay, now we need those test cases again. Let's go back to our README. I'm going to copy everything they've given us here, and then we'll paste it in, and now we'll turn these into a test. So we don't call, sometimes we call it solution. Today we're calling it matrix. So let's see, matrix.rotate, and we'll rotate that thing, which seems good. And we expect to get back this. We'll put a comma, we'll move this up, paste, and align all of our stuff. And we can move that up a line. Okay, there's our first test. Let's go ahead and do the same with our second test. So we're going to rotate this matrix, and we expect to get back this. So we'll cut that and then go up, paste it, make this one line and even that out. How does this look? Any syntax errors? I don't see any. Let's go ahead and run this and Ruby will tell us. Okay, I don't see a syntax error, but it is telling us our matrix file does not exist, which we expected, right? So let's create it, matrix. And we have matrix, and the method that we're testing is called rotate, which takes a matrix. Let's run it one more time. Okay, great. We know we want to, at the end, return our matrix after we do some stuff, right? So I'm gonna leave that in there now, so we don't forget to return. Run it again. Okay, so here's our failure. This makes total sense, right? We're expecting to get back a rotated matrix, but we are getting back our original matrix. It's because we're just returning our original matrix. So now we have to think about what we actually want to do here. And we've done a problem kind of similar to this in the past, like manipulating a 2x2 matrix. And we can use a similar strategy for this one. So I'm thinking about doing it in 2 steps. And it's gonna be hard to, I wish I can draw for you, but I'm not equipped for that right now. But let's grab that first example and let me show you what I'm thinking. So let's go back here. So this is our input here. And this is our output here. And we'll go ahead and erase these commas. We don't need them here for just thinking out loud. So we need to get from this to this, and we can only do in-place transformations. So what I'm thinking about doing is walking through the array and swapping numbers diagonally. Because we essentially need this column to move up into this row, right? So let's just get the numbers up there, and then maybe we have a step 2 to fix the numbers. So walking from this corner, the upper left corner, down to this corner, the bottom right corner, while swapping numbers. So I'll do a couple steps by hand here so you can see what I'm talking about. So we're gonna start with this. And then first step is gonna be to start with in the upper left-hand corner, and we're gonna do a diagonal swap. So in this case, there's only one number here, so there's nothing to swap. So nothing's gonna happen in this first step. Now let's go to the second step. Now we're gonna do a diagonal swap here. So this is gonna be swapping 2 with 4. See the slant that I'm talking about here? So our second transformation is gonna be 2 swapping with 4. Now we do our next swap, and again, it's gonna be diagonal. So we're gonna go from 3 down to here, this diagonal. And so we're gonna swap 3 with 7. So that's gonna look like 3 and 7. And then I guess we might as well just finish this example. We'll keep walking down, and now we do our next diagonal here, which is 6 and 8. So we're gonna go 8 and 6. And then now we've got one more swap to do, and that's gonna be swap 9 with itself. So now if I erase all these intermediate steps here, we've started with this. We now have this by just swapping diagonally all the way across, and this is what we want to end up with. So notice we're not there yet, right? But there is a step 2 we can do now. So what we have is 1, 4, 7 on the top row. What we want is 7, 4, 1, right? Which is reversed. Same with the next line. What we have is 2, 5, 8. What we want is 8, 5, 2. So it's gonna be reverse. And then obviously the same with the last line here as well. So swapping diagonal gets us pretty much there. The last thing we need to do is reverse everything, which is going to be matrix.each reverse. Ruby gives us a reverse method. Now we could write this ourselves, but we don't need to do that. Ruby gives us a way to reverse an array. So we'll just use that, and we're gonna use reverse bang so it does it in place. So I'm actually gonna keep this code and put it down here because that's gonna be our last step. The step that we have to write now is this, the swapping diagonal step. And we can do that with a nested loop. So all we need to do is loop through items from the top left to the bottom right. Okay, so we'll start at 0, which is the index at the top left, and we'll go up to the size of our matrix, -1, and this can be X, right? Now we need to do our Y slice, and this is what we're gonna use for our swapping. So that is going to go diagonally down, so it's going to shrink in size with each step. So we're gonna go from X up to matrix size -1, and this is gonna be Y, and then here we can do our swap. So we're gonna take matrix of X, Y, and I'll write this explicitly here for a second, and then I'll show you a little shortcut we can do. So we can take the variable in matrix XY, save it to temp, and then we can take matrix of XY and get the element at matrix of YX, just swapping X and Y. And then we'll do that one more time. We'll take the value at YX and give it the value at XY that we saved into temp. Let's leave it like this for now and see if it works. Ta-da! Okay, so both our tests passed, that's good. This can be cleaned up though. We don't actually need a temp variable. Let's use commas. So Ruby lets you kind of do like you do double assignments. So we can actually do matrix XY, comma, matrix YX equals matrix YX, matrix XY. Okay, let's run it, make sure we didn't break something. Okay, perfect. We did it. I wonder now too, no, it's okay. I was gonna say, technically we don't even have to return our matrix because we're just doing it in place. But I don't want to really rewrite our test because right now our tests are testing the return value. Actually, I wonder, what does that return? Okay, yeah, that'll work. We can at least remove the explicit return statement. Okay, sweet. So this is looking good. Let's go back to our test, add a couple edge cases here. So we've got an odd number, 3 by 3. We've got an even number, 4 by 4. Let's add a maybe an empty input, and then we'll add an input with a single element. So if we pass in an empty input, we expect that to give us something empty, right? So let's do matrix.rotate of empty. So if we pass in something empty, we expect to get back something empty. There's no rotation happening, right? Let's run that. Okay, great. Let's do one more, which is one element. So if we pass in one row, so it's gonna be an array of arrays of 1, then we should get back the same thing here, right? Let's try it again. Okay, I think we're good. Let's put this into a commit and push it up onto GitHub. So this is gonna be add the solution for today, which is the 4th of March. And push that up. Cool. That's it. So we've seen a matrix problem like this before in the past, so it's kind of easy to connect it to the last one we did. Another way we could have did this a little bit more efficiently rather than going through everything multiple times, if we were allowed to use space, instead of having to copy in place, we could have been a little bit more efficient, but then we would have had to have an array of the same size as our input array, and the question asked us just to limit our space instead of worrying about time. So that was fun. Yeah, thanks for joining me. We'll see you again tomorrow. Bye.